Hi, I will be explaining the Theorem 4.4 that says that the medians of a triangle meet at a point called the centroid. So first we assume that there's a triangle ABC. Then we say that the midpoint of AB is D, and the median is DC. Then we say that the midpoint of AC is E, and the median is BE. Then we say that the area of, we also say that here, this median right here, we have to prove that AG is also a median, because if it's a median, then it would pass through point F. So we say that point F is the intersection of DC and BE. And we have to prove that AG is a median, okay? So we say that the area of ADC and the area of BDC equal. Then we also say that the area of Then we see that the area of ADF has the same area as triangle BFD. So ADF has also the same area as BFD. So these two triangles. Then we say that the area of triangle AFC is also the same area as the area of triangle BFC. So this triangle and this triangle. Okay. Then we say similarly that the area of that looks like two A's. Let me do that again. That the area of triangle AEE is also the same as the area of triangle EBC. Also, the area of triangle AFE is the same as the area of triangle EFC. We also say that the area of triangle AFB is the same as the area of triangle AFC. Okay, so basically what we're saying is that because we split them in half, these triangles have the same area. We're not saying that they're the same, but they just have the same area. So using this, we also can find the height of obtuse triangle AFB. So this triangle right here, let me use a different color. Right there. Okay. And to find the height of obtuse triangle AFB, we must extend AF. We must extend AF to make a right angle with B. So this line kind of goes upward, so we'll just extend AF to make a right angle with angle B. Like that. And let me make this slightly smaller. Put this point G right here. Let me draw this another way so that you can see it a little bit better. Yeah, because right here it's not going to show up as. Okay, I'll draw this a little bit better here. That way you can't really see. I'll draw this one right here. Okay, sorry. This way it's more evident. Okay, and we've got okay. So right here, and the midpoint over here. Okay. This is F. This is G. Okay. Okay, starting over. So we're saying that obtuse triangle right here. We want to find the height. So what we do is that we extend AF to make a right triangle with B. So about right there. Okay. And we're going to name this point right there. These are on the same line. So we're going to name that point H. So we extended AF to AH, and then we are going to extend AF to make a right triangle with C as well. So we also want to find the height of this triangle. So what we do is that we make a right angle right here, and we extend AF to AI. So that's point I. Okay, so I will draw this segment right here separately. So this is going to look something like and then we're going to have something like C. Okay, this is not drawn to scale. Okay, and here we have like that. So this BH is the base, it's the height of triangle BAF, and then IC is also the height of triangle FAC. So because B and H both make right angles, so, whoops, okay, sorry, this is supposed to be a right angle. Just change it like that. Let me extend this. Like that. This is C. Hopefully I'm making sense. Okay. Okay, so this is a right angle. This is also a right angle. We can say, this is a very bad drawing, I'm sorry. So we can say that since B and H, since BH and IC both make right angles with AG, so this line is AG. Then BH and IC are parallel. Okay, because two right angles make a parallel line, two parallel lines. And since triangle AFB and triangle AFC have the same area here, then, and they also share a base of AF, so here what we're saying is that these two triangles have the same area and they share base AF. Then what we can say is that, BH equals IC. So the heights equal each other. Then by angle, side angle, we say that triangle BHG and triangle CGI are congruent. So I guess B, this is G. So BHG and CGI are congruent triangles. Then, therefore, BG equals GC. Okay? And G is the midpoint of BC. Therefore, since G is a midpoint, then it must be true that AG is a median. And since F is on AG, then all the points meet. Sorry, all the medians meet at some point in the middle called the centroid. And I don't know if I should write that down, but basically, I'm done. That's the proof. I hope it made sense.